This panel and this fireside chat for sure will be an exciting one, and it's the last of the day, so bear with us. Yeah, Ilya, hi, great to see you. Do you see us already?
Hello. Hey.
Okay, perfect. Now we do. So, first of all, Ilya, thanks that you took the time to be here. I know as a newly father, there's a lot to do. And next time for sure we'll meet up in Lisbon or in Frankfurt. But just to give you a scene of the audience, so the audience, we mainly have investors here, family offices, institutions, corporate investors, and private individuals. So we just had a keynote speech about generally AI. So what we will be talking about is one step further, kind of the intersection of AI and Web3. But to give you a brief introduction about Ilya, Ilya is the co-founder of Near Protocol. At the moment, if you look at it today, valued at around $7.5 billion, which is a shared smart contract blockchain, and Near AI, which is an R&D lab building toward user-owned AI. Before Near, Ilya actually worked at AI research at Google and co-authored the landmark paper, Attention is All You Need. Just to give you a perspective, this is the basic concept and this was the basic principle generative AI was built upon. So if you would think of the Rolling Stones, Ilya was one of the band members. Yeah, you were in the Wall Street Journal, on CNBC, Bloomberg, Time Wired, New York Magazine, Vanity Fair. I don't know what that article I have to find. Financial Times and TechCrunch. And yeah, I think the most interesting part is your founder story and your background and how you transitioned out of this Google ecosystem in kind of building your own. And you, however, left Google before that paper you have written and contributed to actually was published. So first of all, thinking back to that paper, what exactly were you working on? What was the breakthrough and what is the relevance of that paper today?
Yeah, so first of all, thank you for having me and sorry for being remote. Indeed, I have a 2-month-old here. I joined Google with the idea that natural language is how we're going to advance ability for computers to understand us, to be able to think, and to be able to effectively change how we interface with computing. And so my team was specifically owning kind of how do we understand language, and the way to test this is to ask questions. And so we were building question answering systems. And so before Gemini and before kind of this Gen AI stuff, if you ask questions on Google, it would actually try to answer some of them directly. And so we were providing effectively models for that system. Now, the big challenge we always faced was what we used in research was interesting models. And we actually had something like ChatGPT effectively available, but it was not very scalable. It was slow. If you wanted to read, few articles in search results, it would take a substantial amount of time to do that. And so training was slow, inference was slow. You wouldn't be able to put this in production. And the problem we were trying to solve is exactly this: how to train these models at really big scale, how to have a really long context that can have lots of articles and knowledge and able to process it quickly. And so transformers have introduced the architecture which can deliver on all of this. It is able to have long context. We know some of it now scales to millions of tokens. And it's in turn is highly parallelizable architecture. It fits really well on GPUs and similar kind of hardware architectures to train these models at massive scale, right? And so what in turn OpenAI took this architecture, scaled it up, trained on ton and ton of data in this pre-training fashion, and effectively that was GPT-3, and GPT 3.5 was fine-tuning on specific instructions, which gave us kind of first ChatGPT product. And T stands for transformers in GPT. And so now, effectively, all of modern machine learning, one way or another, using those technologies, these transformers, and it's applied across images, across time series, and other use cases.
So it seems like you had a pretty good thing going at Google. So why did you leave? And how did that lead to Near AI and then Near Protocol?
Yeah, so I was in the research team, which obviously gives us a remit to develop kind of new technologies, but it's very challenging to bring this new technology to market out of the research team. And also from a perspective of Google, anything that's not clearly a hyperscaler product is really hard to turn into a proper production offering from Google. So and we kind of seen this, right, that Google have not tried to launch something like ChatGPT, even though internally they've had this technology for years. And that's because it's very risky. There's a lot of things that can go wrong, and they go wrong all the time, effectively now. But as a startup, you don't have that much to lose. And so you can actually bring this to market. You can start collecting data. You can start improving your product. You can start improving your models from that. And so that was kind of the idea I left with, which was using these transformer models now and applying them specifically on teaching machines to code. And this is one of my fundamental beliefs, that effectively coding will get obsolete. And we see this happening now kind of quicker than before. But in 2017, I was like, hey, this transformer models is going to be able to write code. Like we as humans, we can stop writing code and instead instruct it what to do. And so we were teaching machines to code back then. And the challenge was, obviously, we did not have massive amounts of funding at the time. We did not have the GPU scale. So we were trying to be smarter. We were trying to collect more interesting data. So we had a lot of people engaged around the world, mostly students, who would write small code for us, small descriptions of code, and we would use that as the training data for our models. And the challenge we faced was paying all of them as a US company was actually pretty complicated. We had people in China who didn't have bank accounts, and so we OTC'd money into WeChat to effectively pay them. We had people in Eastern Europe, like I'm from Ukraine, PayPal doesn't work there. You need to use Payoneer. Some Southeast Asia doesn't work either. And so we started looking at blockchain actually to just solve our own problem. How do we pay people? How do we pay these contributors at scale, programmatically, for the work they're doing? Now, this was already in 2018, and even back then, the fees on Bitcoin and Ethereum were way higher than actually what we were paying people for kind of jobs they were doing. And so we were kind of started exploring why the fees are so high, and kind of stumbled on the fact that none of the systems have been built for scale. None of them built for kind of users really onboarding at scale. And that's how we went from Near AI into Near Protocol. We're like, hey, actually, we should solve this problem because we would have used it, and there's other people who would use scalable, easy to use blockchain. But then we could use it ourselves to then build other things, including kind of this crowdsourcing system and other applications. And so that's kind of started the Near Protocol journey in August 2018. We launched mainnet in October 2020. It's been running. It never stopped. It's has about 30-something million monthly active users, kind of ton of value transacted. And since then, we actually restarted Near AI. We've had built this crowdsourcing platform that uses now Near, and we have thousands of people working there. And now we also, and we'll talk about it, building models and building some of the products on top of it.
Yeah, so I just read that Near Protocol has unveiled an ambitious plan to build the world's largest open source artificial intelligence model, which would be actually 3.5 times bigger than Meta's current open source Llama model. Can you explain in a non-technical way, what advantages Near has to other systems?
Yeah, so I would say like there's a fundamental problem with open source right now, which is there's no way to monetize it, right? Meta effectively kind of donates the product of hundreds of millions of dollars in research, and they expect some of it gets back in some goodwill, maybe in some tooling, but the reality is they not actually have an effective way to monetize it, which also in turn like. And we can align with that, like Mark is aligned with values on supporting open source, but in reality is like if there's no good business objective, right, it's really hard to for like investment to continue at the same scale. And then the other side of this, like the closed source models can always effectively benefit from whatever people do in open source, and so you have this major disbalance. And closed source has not just the fact that it's closed source, it's the fact that these models are optimized for profit of those companies, right? The specific products they're launching, they're always going to be A/B tested on what's going to generate the most value for the company that launched them. So that's kind of the state of the world. Now, what has changed this year is a new set of hardware that allows to have verifiable and private computation. And so Intel has released the new chips, the 5th generation, with so-called trusted execution environment. The NVIDIA H100s and B100s already support working with that hardware as well. And what this enables is a new feature. And this feature is you can run compute on somebody else's machine in such a way that owner of that machine doesn't actually see what's happening, what computation you run, what data went in, and like the hardware guarantees that this execution happened. So this is a very unique feature. And again, it's only possible effectively this year, like as of a few months ago, like it's not even fully rolled out. Like the hardware is not fully available yet in all data centers. Now, what this enables to do if you combine it with blockchain is actually train in centralized or decentralized way models in such a way where the training itself happens inside trusted execution environment. And so the code and data that you use are open source. Everybody can inspect what went in, but the resulting model has parameters encrypted. And this parameters encrypted can be used in any other GE hardware, right? You can have your own GPUs and run this. You can build on top of it. You can fine tune it. You can do everything. But it runs inside this specific container, which requires for a payment to go back to the builders of the model. And so that is really kind of the innovation here. If you combine the hardware and effective blockchain for micropayments, you're able to create a monetization model for open source. And while you're doing this, you're also getting actually private inference, which everybody wants because you don't want to leak all your data to inference providers, wherever they are. And so this is actually a very unique opportunity that we are very, very well positioned to build because we have kind of all the infrastructure to do the payments and to do the facilitation, to do coordination, to do fundraising, to do this kind of coordination of TE providers. And through that lens, we can actually coordinate now researchers to develop models, right? Because before, if you try to bring a bunch of researchers from academia, they develop new models. But again, because you don't have a sustainable business model, you're not able to raise funds to fund building a larger model, right? To give you an idea, 7 billion parameter model costs about $8 million to train. 70 billion is about 40 million, and the 1.4 trillion parameter model costs about $160 million to train at the current costs. The GPU costs went down over past kind of 6 months. So now, if we have a monetization model, we are able to raise funds to actually invest into research and training these models, and then these models are now used kind of in permissionless way by anyone to for their own use cases in private way. If you are enterprise, you can use it on your own hardware, but you still need to able to pay a little bit for kind of for every million tokens back to the whoever trained the model and whoever provided capital. So that's really the innovation kind of we're bringing together.
Oh, that's great to hear, and especially these inflection points are seeming to come closer and closer together. I remember you stating that Near's mission is to build a new and more open digital economy, taking a little higher level now. What is your open web vision?
Yeah, so I really believe that AI will transform how we interface with computing, right? So this is, I mean, the same belief why we started Near AI. And if you imagine what is going to change is that your device, right, where your AI assistant runs, first of all, it will know a lot more about you because you can trust it with your data. It's not owned by some company. It's not leaking it to somebody else. And so it's able to predict and act on your behalf a lot more ways than currently any applications can. Now, because of that, you actually don't need, for example, Google. You don't need to go and search for a specific product. Your AI can go and scan effectively all the other providers and find the best option for you, right? So instead of relying on Google, getting you 10 blue links or even more, getting you specific ads, you effectively have your AI assistant doing all of this on your behalf. And there's some infrastructure involved in that, but kind of high level, broadly thinking, you have now your AI assistant who directly going to come into commitments, into contracts with other partners, goods, service providers, AI agents. And it removes all of this middleman infrastructure that's been built on the internet, right? All the aggregators, all the payment processors that exist right now. So this releases effectively trillions of dollars annually in the revenue they capture to be distributed among the infrastructure that provides this, as well as benefits users and benefits the service providers themselves. And so that's effectively the vision. It's removing all this middlemen, where AI assistant is your interface to the internet, to computing, to kind of what gets done. You can have agents that running on background that executing specific tasks. I used the example where for example, when the war in Ukraine started, like we were procuring things from Germany and from Poland and sending them to the border and then having volunteers pick it up. So all of that can be facilitated by AI agent who, actually executing those actions directly with the providers, directly with individuals or their AI agents. And so that is effectively the vision where the web is open, but it's actually going to get reshaped because of the platform shift that we see with AI. And blockchain is really the financial facilitator, the identity facilitator, the markets, creating this global market where anyone can participate in an effective way.
That's a very important point, and maybe we can double down on that. Why is decentralization and open source so important, and how do you see the world would be ending up if AI is not running decentrally but remains controlled by big tech?
Yeah, I mean, actually, I caught up a little bit of a previous speaker, and I think the point I also use is that this technology is effectively going to become for control, not just for profit, right? Because if you're able to have, like, let's imagine OpenAI tomorrow decides to turn off Germany and say now you don't have access to OpenAI, right? And we're assuming this AI technology, I think very rightfully so, is massive GDP factor. Like for growth and kind of optimization. Now just the whole country is removed from ability to use this technology. That is a very, I would say, like, now when CEO of whoever that is at the time of OpenAI comes to Germany or any other country, right, they have this massive control power, right, that if they want something and like they will decide, to turn off the country, like that's a massive overhang of power. If they effectively control, 20% of GDP is powered through that. So the reality is we need an alternative that is not controlled by a single party. It's not controlled by a single company. Ideally, it's not even controlled by a single government and kind of its rules, but it's actually truly enabled by all of the kind of countries and parties and communities. And, you can have your own like custom Germany version, for example, that maybe runs on German hardware in case some other hardware doesn't work, etc. But you can have all those different versions and kind of forks and variations, and you're able to, for example, if Germany wants to build a German version of this open source model, they can use the base model and fund fine tuning on top of it in our model that we're building and get a specialized model for Germany. I'm just using this as an example, but kind of it applies across every community, right? If specific like artists want to have their own kind of community-owned model, they can do that. So I think that it's really about this opportunity to move away from single party, whoever that is, having massive control over what effectively should be kind of public good, which is this intelligence, and really allowing it to be controlled by the users community and kind of democratizes access.
Yeah, a more let's say an extension of this question would be in our day-to-day life. If I look around the room and also taking myself, it's not always that we pay attention to personal data or data itself. How important is it to own this own data, or why should we care?
Yeah, I agree that like most people usually don't care, and the challenge is always like when you do actually start to care, it's too late, right? I mean, OpenAI have multiple times already like accidentally had somebody else's data show up in somebody else's account. They, by the way, accidentally dropped some data that is related to a lawsuit with New York Times. So this goes to the question of, I'm sure most of you have not experienced identity theft, but I know people who have, and like that usually happens because of a data leak from some of the companies that they gave their data. So the reality is it's effectively always like it's not the priority feature for the user, but having it actually enables so much kind of more trust in the system and so much more kind of confidence that you're not going to have problems later. Now, from a developer perspective, like I'm as a founder of a company, if I can use a technology where I don't need to deal with GDPR, with HIPAA compliance, with private user data, with effectively data leaks, etc., that's a massive enabler, right? This is like removes so much of additional kind of infrastructure and operational costs that I need to deal with. So the reality is actually it's going to be developers who choose to use this technology because it enables them to not deal with all of those complications and instead really just deliver the core value to the user. And you still like in the architecture of building, like if you're building agents and you're running them inside this kind of private enclave, you're still able to, for example, extract specific information that you need for training your model or for improving your product. So you can still have analytics, like high-level analytics, but you don't need to deal with that, specific PI data that users have. And that, again, as a person who've like needed to deal with GDPR, even for like the blockchain type things, like that's a massive unlock, right? Removing a lot of operational costs. Right now, most startups are not GDPR compliant, right? That's like just general truth because it's just like so much work required, and it's not getting enforced right now for startups. I mean, even big companies are not GDPR compliant, but that's a separate story.
Yeah, so diving a little down the road of the combination, intersection of AI and Web3, and our kind of vision and thesis is that actually combining the technologies makes them more powerful. So what unique problems can the combination of AI and Web3 solve that neither technology could solve or address on its own? Like how do both technologies complement each other?
Yeah, so I mean, there's a whole set of effectively use cases where they come together. So blockchain is very good at effectively defensive things. So for example, I mean, I was just talking in Brussels, and the big question is, fake fake photos, fake information, right, spreading. And so right now already, again, the devices like cameras and phones have actually cryptographic signatures on the photos. The problem is nobody posts the original photo because it's too big of a size. You need to resize it, maybe you touch it up anyway. And so you can have a private, like kind of verifiable compute applied over it, so you can actually maintain the log that this photo that's published in this place is effectively coming from this set of actions, this set of algorithms applied, instead of coming from fully AI generated. So this is an example of something more defensive where we use cryptographic identity that needs blockchain signatures as a way to defend against potential kind of AI misinformation. The example I used, was like monetizing open source, monetizing kind of private execution is definitely something where without blockchain, just cannot do it, right? Like you cannot, Stripe pay into somebody's TE you want to run the inference on, and so you kind of need those use cases where the micropayments are able to be facilitated effectively through just set of cryptographic primitives. The other example is, copyright is effectively kind of a technology from 1700th century. We have a new, Gen AI is like replacing what Gutenberg Press did from like a kind of how we're going to interact with information, right? Instead of reading books, we're going to be now reading summaries of what our AI assistant is providing us. So what is the new kind of framework for royalties, for kind of rewarding people who have created content in this new model? Well, you do need, again, some form of like traceability, identity, a way to kind of ensure that this data went in and kind of understand how much of the impact is done. So this is where the combination of AI methods to evaluate how much impact this data did and micropayments and kind of distributing payments across, millions potentially of people will need to come together to provide this product. So this is, again, evolution of both regulatory framework and how it's actually implemented will require blockchain. And so there's ton and ton of these things where, again, AI is fundamentally changing how we interfacing with things. And in turn, like if you imagine two AI agents sitting in two different companies trying to make a transaction, and then they need to go and like reach out to their legal department to set up a formal contract, and then do a billing and invoicing and like all of the things, like that's not going to happen, right? There will be a way to establish a channel to come up with a commitment, and it should be a legal commitment that can be settled on chain really fast. And if something goes wrong, then you go to effectively arbitration and court later, right? So again, it's like leveraging cryptographic kind of payments and commitments, and then still plugging in all of the regulatory system that we need to have for two companies to transact with each other. So all of this is like kind of all those things we're going to be combining more and more and becoming more and more interconnected as we're building these products for real future and for real use cases.
I remember in one of our previous talks, you said that AI is not only the interface layer, and but the scary thing is that it also creates content and takes decision on your behalf. And if big tech is still part of that equation, then also that decision might be profit oriented. Can you elaborate on that issue? Because I think that is an issue really everyone will be facing, and how and what we need to mitigate that problem.
Yeah, so I mean, the simplest example, I'm sure a lot of you already using ChatGPT or Claude or something for your own internal like fund analysis, research and other things, right? And so right now you have no idea what actually went into the decision and the output you see, right? Somebody could have overtrained the model to say that you should buy this stock or you should not buy something else. Somebody can. And I was like talking about this idea, and then I've heard actually somebody's building it, so I'm now scared that I've like suggested this. But you can actually run effectively an ad auction on every token you produce in the model, and sell to whoever pays to prioritize different tokens from top priority in the list. So to give you an example, you're looking which car should I buy, and it should suggest Porsche, BMW. But in America, for example, somebody paid and it suggests, Ford and Chrysler, right? And like, that's not what model was trained on. This is just like post-training, effectively, optimization that, makes money for the company that you're looking at the results. And the problem is like, you have no idea, like what you're looking at. Is it coming from like statistically significant set, or is it just a product decision that somebody made to give you this idea, this data? Now, even more, like a little bit more on the paranoia side, right, is somebody in that company can be specifically targeting a specific actor, right? And because you're logging in with your email, it's, for example, your corporate email, they can effectively say, like, for this for this corporation, the responses should be biased toward this way. Now, a little bit more like realistic examples is something that I've done at Google. You just filter out data because you're making some decisions while you're training the model, and you filter out data based on some set of criteria. So, for example, Barack Obama is born in Kenya is something that's very popular on Fox News website back in the day, and so I would filter out Fox News because it was messing up my eval set, right? And so it wasn't like because I was trying to avoid, Republican point of view. It was just kind of naturally, instead of trying to figure out how to sort this data out. And so now, the model trained on that, on filtered out. If you remove Fox News, you remove, a few other websites like this. Now you don't have in your data anymore a different perspective, and so now your model is very biased toward one way. And again, you have no visibility into those decisions, and you're not able to evaluate like kind of the model you're interacting with, what kind of biases it will have. And again, this is where open source is extremely important because you can go and inspect what went into it, right? And then if you don't agree with it, you can literally fork it, right? And retrain it in a way that you think is right. Or again, fine tune with, for example, Fox News on top to make sure it has like better representation. So that's again why it's really important to have all of this information out available for people. And again, it doesn't need to be everybody's like themselves inspecting stuff, but like there can be very easy tools where you can double check if the model you use had this thing in the training data, or find all the examples that mention specific thing, etc. And also, like from what we're building, the output will be you'll have a signature that it came from running this model and this, maybe agent code or assistant code on top. And so that it's not trying to mess up with you. There's no like man-in-the-middle attacks effectively for it.
So maybe you can summarize what are the key features we need to overcome that, and especially the key areas you should or we should focus on when looking at AI and the potential side effects it might have, and kind of in the combination of AI and Web3.
Yeah, so effectively we're looking for, I call it user-owned AI, which is AI models that are open source, that you can inspect what went into it, and that they are optimized for the user's success, not for some company's success. And so that's kind of the critical framework. Now, for that to work, we need a monetization model that is able to actually monetize the outcome of this open source model. That's kind of what we're building. And then from there is all of this can be used inside effectively a new economy that's been built where AIs, be that your personal AI, your company's, AI agents, or somebody else's agents are actually being able to do commerce directly. Obviously, with whatever checks and balances that you want to ensure, with whatever, approvals, but they kind of going to start doing commerce directly, right? Instead of you, going to Amazon, and then Amazon has a reseller, and then the reseller has, another reseller, and then that goes to factory. Your AI agent can just go to the Chinese factory directly and, order whatever you need from there without any of this middleman and effectively any of this cuts being taken. Right. So again, this is like new commerce is going to be built around that. And so I think like that's kind of the data, the commerce, the kind of privacy, and the like open source and in turn also ability to reward kind of creators. All of these pieces are effectively powered by Web3 to turn AI into really kind of the future we all hope, not the future we're all scared of.